Okay, so the last class period we talked about ionic and covalent bonds. And in this class period, now that we know the definitions of them, we're going to learn how to draw Lewis structures to represent them. So in either the first part of class or after you learn this, you'll be learning about covalent Lewis structures. What we're going to focus on is ionic Lewis structures first. And so I'm going to pull this sticky note up real quick. So this is the definition of an ionic bond, and this actually really helps explain how we're going to draw this. And so I bolded a couple of these words here. An ionic bond is, let me pull that back, a bond where electrons are transferred from an element with low electronegativity to one with high electronegativity. So let's do an example right here. So sodium chloride, NaCl. Sodium has an electronegativity of 0.9, and chlorine has one of 3.0. And so if we do that math there, it's a difference of 2.1. So this is clearly going to be ionic. And sodium is so much less electronegative, and chlorine is so much more electronegative, that chlorine is going to steal at least one of its electrons. So this is what this looks like. A Lewis structure of sodium has 1 valence electron, and chlorine has 7. Not doing a great job of these. Okay. Now, the point of bonding is that atoms get a complete octet. And if you look right here at chlorine, it's so close to getting an octet that really all it wants to do is just take that electron right there from sodium and give it to chlorine. And if you remember, sodium's pretty happy with that too, because now the level below this valence shell has 8 valence electrons. So that's also a complete octet. And so what this is going to look like is Na has given up an electron. So if you lose a negatively charged electron, you're going to be positively charged. And then chlorine, and we're going to separate it with brackets. Chlorine now has its complete octet. There we go. And because this now gained an electron, well, if you gain a negative electron, you have a negative charge. And the reason why this is such a good representation is now you can see if this has a positive and this has a negative, they're going to stick together just like magnets. So this is actually the complete answer that I want you to write. So when I ask you to draw the Lewis structure, draw the individual Lewis structures and then draw them here once they've transferred their electrons. So let's see you do LIF. So what you can do right now is pause this video and try to draw the Lewis structure of LIF, just like I did right here, and then we'll check your answer. All right, so just like last time, you should have drawn the Lewis structure of each of them individually. So lithium has 1 valence electron because it's in the first group, and fluorine is in the 17th group, or 7A, so it has 7 valence electrons. Again, fluorine's looking for an octet, so it wants to take this 1 valence electron. And what's going to look like is lithium has a positive charge because it lost a negatively charged electron. And fluorine, I'm not doing a great job with those valence electrons, has 8 valence electrons, so it has a negative charge. So this answer that you drew in your notes, this is what it should look like. Okay, so I'm going to clear this right now because what we're going to look at is a different example. Okay, so the example we're going to look at here is when sodium and oxygen form a bond. And when that happens, it's actually going to be Na2O. And so we're going to start off with the same idea. Sodium has 1 valence electron because it's in the first group. And then if it's going to join up with oxygen, oxygen is in the 16th group. so it's going to have 6 valence electrons. And so the point of bonding, to go back to what we started off with, is that both of these atoms get a complete octet. So sodium wants to get rid of its 1 valence electron, and if it does so, then sodium will be pretty happy. It got rid of that, and now it's the shell that's below this valence shell will have 8 valence electrons, and sodium will be happy. But what we see right here is that oxygen is not happy. It's still got this one spot here. So that's why this 2 is here. It's because in order for oxygen to get a complete octet, we need 2 sodiums, each of them to give oxygen 1 of its electrons. And so if we look at what this is going to look like, one of these NAs has got a positive because it lost 1 electron. The other one also lost 1 electron. And then oxygen here, it gained 2 total electrons. So it had 6 valence electrons, now it has 8. And if it gained 2 electrons, it's going to have a -2 charge. So all I'm really focusing on here is, did every single atom get its octet? Sodium lost its 1 valence electron, this one lost its 1 valence electron, and oxygen went from 6 to having 8. So, again, pause this video and try this example, Li2O. And then after you've done this example on your paper, hit play again and I'll show you the answer. Okay, so you might have figured out that if it says Li2, there's clearly going to be 2 Lis. I'm going to start off by doing just one though. So we've got Li with 1 valence electron, we've got oxygen with 6. Lithium, because it's got a much lower electronegativity, will transfer its electron to oxygen. But oxygen hasn't reached an octet, so that's why we need our second lithium to go in there. And then what this is going to look like is Li with a positive, Li with a positive, and oxygen with 8 valence electrons. Man, that's bad. And it's got a -2 charge. Okay, so both of those, Li2O and Na2O, were very similar. So I'm going to give you 2 different ones. The concept is the same, but you won't have exactly the same looking answers. So again, I'm going to have you pause the video in just a second and try these 2 on your own. The first one is MgCl2, and the second one is BeS. So pause the video and try to do those 2 Lewis structures. All right, so the first one, Mg, magnesium has 2 valence electrons because it's in the second group. And chlorine has 7. 1, 2, 3, 4, 5, 6, 7. So in order for chlorine to get its octet, we're going to transfer that one there. But magnesium still has an extra electron there that it needs to get rid of. And so that's why it's MgCl2. There have to be 2 chlorines so that this electron can be transferred right there. So our answer is going to look like Mg, and because it lost 2 electrons, it's +2. And then chlorine, over here, it had 7 valence electrons, it gained 1, so now it's got 8, and because it only gained 1, it's got a -1 charge. Then I'm going to do that again. Okay. If the whole process here makes tons of sense to you, you can skip to the answer for this next one, but I will also draw it out from the beginning in case you want to see that. So Be is beryllium. It's got 2 valence electrons, and sulfur has 6 valence electrons. And so what you can see here is Be is going to give up 1 of its valence electrons, and Be is not happy yet. It still has an extra 1 to give away. But what you can also see is sulfur still has 1 more spot. So actually, Be is going to give 2 of its electrons to sulfur. So when we look at what this looks like, Be has lost 2 negative electrons, so it's going to be +2. And sulfur has gained 2 negative electrons. so it's going to be -2. In all of these cases, what we're looking for is, does this positive charge cancel out the negative? +2 and -2 cancels to be 0. +1, and then there's a -1 and a -1, that's a total of -2, cancels out. Okay, so I'm going to now put 3 examples up, and you're going to pause the video and try all 3. And I am only really going to put the answers up here. So I'm going to clear this off. All right, so those are your 3 examples. Try and do those on your notes right now. So you're going to pause the video, and then I'm going to just put the answers up completed, but I'm not going to necessarily record the way to do it. All right, pause the video now. All right, so go ahead and check your answers here. Oh, actually, I did not draw those arrows there. So these would be your complete answers. Make sure the charges are correct and also the number of valence electrons. Also, obviously, the number of atoms that there are of rubidium versus chlorine or beryllium versus oxygen. The last 2 examples that we're going to do, sometimes you'll get a question where this is not given to you, this formula. And so I'm going to pull a sticky note over right now with a new type of question. Okay, so there is the new question. Draw the bond that would form if lithium and chlorine were allowed to react. And so now we don't have a formula, but what I do have, let me get a brush here, is I know that lithium is going to react with chlorine. And so this is easy enough to figure out. If I know that lithium has 1 valence electron, and I know that chlorine has 7, I can already see that when lithium gives up its 1 valence electron, chlorine then already has its full octet. And so I'm good to go here. Lithium has a +1, and chlorine has now 8 valence electrons, and because it gained 1 electron, it's got a -1. And so you can always use that idea. Do both atoms have 8 valence electrons? And if they do, you're good to go. Okay, so I actually forgot to pause that there, so you saw me typing it. But so draw the bond that would form if magnesium and bromine were allowed to react. So same way I'm going to start here. Magnesium plus bromine. Magnesium's got 2 valence electrons. Bromine's got 7. So I can see that if bromine's got 7, it just wants to get 1 more. So if I give it its 8th valence electron to get an octet, magnesium's still not happy here. And so what I'm going to do is add another bromine. When I add another bromine, it gives 1 more spot for that valence electron to go to. And so what our answer looks like is magnesium +2 and 2 bromines with each -1. Going a little bit fast now because these octets take a while to draw. Okay, so I'm going to give you 2 examples now for you to do, and then when you are finished you can move on to the next activity. I'll also put the answers up. So here are your next 2 examples. Alright, so I've done this on a sticky note right here. Here are your 3 examples, just because my handwriting's pretty awful on this. So pause the video, do all 3. If you want to do one and check it, I will put them up one at a time, but there'll only be a couple seconds between them. But so pause it now so you don't see the answers before you do them. Here's the first one. I'll give you a second to pause it before the second one. Here's the second one. Again, pause it before the last one. And here's the last one. So now that you've checked your answers, you can move on to the next.